Hi, this is still part of the review. It's a word problem, and it says a ball is tossed from the roof of a building. Okay, so we have a building here and a ball is tossed off of it. And they give us the equation. So that is huge, right? That equation is talking about the traveling of this ball. So every second that goes by, that's what's going into X. So if I plugged 1 second in, my answer would be where it is in this parabola, like the height of it. Okay, so there's a few things that that are important parts. Usually where we start, the highest point and how long it took to get there, right? That's the axis of symmetry. And then when it hits the ground. So those are the kind of key things that we're going to be talking about. And usually it's the height and when it hits the ground. So if this is in standard form, the height of the building is C, and that's right there, right? So right now, and usually in a problem, I would be a little more wordy and say feet or inches. Obviously, it's not going to be inches, but so we're going to say that the height of the building is 100 feet. That is just C if it is in standard form. Okay. Now, to get to the highest part of the ball, what we have to do is we have to find the vertex. Because this is what we care about right here. Okay. And so to do that, we're going to do negative b over 2 times a. So negative b is 0.4 over 2 times a is negative 0.25. Okay, so 0.4 negative, let me do this, 0.25 times 2, 0.4 divided by 0.5 gives me 0.8. So what that means is in 0.8 seconds, right? If I'm going to write the vertex like a coordinate, in 0.8 seconds, once I plug this in, it'll tell me how high the ball is. So it's taking 0.8 seconds to get there. Okay, so I'm gonna plug 0.8 into here. I already have my 0.8, 0.8 squared. I have to do that part first. Okay, 0.8 squared times 0.25 negative. So this gets me negative 0.16. Okay, so the height is, the highest the ball gets is going to be 100.16 feet. So that is a tiny little toss, right? Just a little arc there. And then the time it takes to get there is just your 0.8 seconds. Okay, that was a quick one.